Griffin wants to move out of his parents' home when he's done with school. So after finishing school, the person wants to leave their home, right? Their parents' home rather. He decides to save 2,500 rent per quarter, right? So he wants to leave home. He decides to save 2,500 rand per quarter. Right? This word save is very, very important. It's an indicator that we are dealing with future value somewhat. Right? Then 2,500, that's the regular payment, which is going to be done every quarter. So the word save is an indicator that there is an investment, right? And future value annuities are investments. The 2,500, that's the amount which is going to be saved every quarter. That is after every 3 months, right? So that's what's going to happen. And this is going to happen for the next 2 years, starting immediately, right? As I shared with you earlier in the morning, in financial maths grade 12, the word immediately is very important when you are calculating the number of payments and ending at the end of 2 years. How much will we have saved up by the end of 2 years if interest is calculated at 9% per annum compounded quarterly? So our compounding period here is going to be quarterly, which is 4 times per year. So first thing, let's list the information we have. First, our X is 2,500 rand. That's our X. Our N, okay. Now N is the number of payments. So if I do a timeline, right? We have got 2 years, right? We have 2 years, but the interest is compounded quarterly. So the total number of ends, okay, it's not 8, but it's going to be 9. But at the end here, I put T8 because 2 years times 4 quarters gives you 8, right? The first payment is made here at T0 because the question says he started saving immediately, which means on the day that the paperwork is signed, the agreement is done, that's when you put some money. So the first payment is here, and the last payment is made at the end of the 2 years. So our N is going to be 8 plus 1, which will be a 9. Okay, because T0 is included. T0 is when the person deposits money immediately. That's our T0. Right? Which means it is possible in this case that, let's say if it was, okay, let's say if you were to save money from next year, 2022, it means the first payment would have been done on the 1st of January, then the second payment on the 31st of January. So the first month, two payments probably will be made. Okay? Or you can say out of the 12 months, one of them is going to have what? 2 payments. That's what it means. Okay, then we need to know what is F. That's the one we will calculate. Our interest rate is compounded quarterly, so that is 0.09 over 4.
So what's
like, how many quarters are in 2 years? How many quarters are in 2 years? It's 2 years times 4, which is 8. Right? Now, which means we are starting from here up to there. But we have to include T0 because T0 is the day that the paperwork is done and the first deposit is put into that savings account. Alright? That's our what? T0. So that T0 has to be included. Right? I'm going to repeat this. As I said earlier in the morning, if I give you 5, if I say how many digits are there between 0 and 10, right? What would be the answer? It would be 11, right? Or rather, okay, 10 is not a digit, rather, but I would say from 0 to 9, how many digits are there? There will be 10. Okay, remember 10 is not a digit based on, okay, on numeracy. So here, our n is going to be 9. It's not 8. You can be tempted to neglect that word immediately, and you end up putting n equal to 9. So be very careful. When you are reading the question on grade 12 financial maths, if you see the word immediately, be very careful how to deal with it. And then the next thing, I'll write my formula f equal to x times 1 plus I raised to the power of n minus 1 all over I. Fortunately, when you write your examination, the formula is provided. If you can manage to memorize it, that would be wonderful. If you can't, then you have to check on the formula sheet. So I'm going to do my substitution. My x is 2,500 times my I is 0.09 over 4, all raised to the power of 9. Then you subtract 1, you close the bracket. Then we have to divide that answer by 0.09 over 4. Then you need to determine the final answer. So you have to take out your calculator, right? Take out the calculator. Okay? You take out the calculator. First, you start by putting the fraction option. Then you put x, which is 2,500. We are multiplying because we have got two brackets, so we have to open bracket twice. Then 1 plus the fraction option 0.09. Then you divide that by 4, and then close the bracket. Put the power option, that's 9. And then you subtract 1 from that result, and then you close the bracket again. Then we are now entering the what? The denominator, which is the fraction. So that will be fraction option is second time 0.09. Then you divide that by 4, right? And you get that answer. You have to know your calculator. Don't borrow a calculator. So this is 24,634 rand and 98 cents. So I'm going to put it here. 24,634, 634,98. It's in rands. Okay, 24,634 and 90 cents. Again, just to remind you, it's financial maths. You always round off your answers to 2 decimal places. The final answer must be 2 decimal places. Is that clear to everyone? Yeah, your final answer must be rounded off to 2 decimal places. Alright? So I've done a second example on calculating f. Now, it's not always the case that you have to calculate f. Sometimes you have to calculate x, sometimes you have to calculate n. So I'm going to do a second example, okay, on calculating x now. So let's calculate x. So this question now is on calculating x. How do I know that? Let's read the question. Now the question says, Amaste wants to save up 100,000 rand. I hope it's used busy. Right? She wants to save up 100,000 rand to pay a deposit. Now check this out. The first amount which is there, that's the amount of money that the person wants to save. So that's our F. Is that clear? That's our F. So F is given here. So she wants to save, or he wants to save 100,000 rand to pay a deposit on a house in 4 years' time. So we have our F here, right? The word save here, it can be a clue that we are dealing with future value annuity, right? So our time period in terms of years, that's 4 years. She makes equal. That word equal is a key word in terms of knowing whether it's an annuity or not. So the word equal, quarterly payments. Okay. And also the word savings and account, starting again immediately. Right? So then the next part of the sentence says, she makes the last payment at the end of 4 years. Right? She makes the last payment at the end of 4 years. How much must she save each quarter? Okay? How much must she save each quarter? If interest is calculated at 12% compounded quarterly. This phrase here, how much must she save each quarter, is a clue that you're supposed to calculate X. Now, calculating X is slightly more complex as compared to calculating F. Okay? So we can draw a timeline first. Right? We have a total of 4 years, but the question is dealing with a compounding period, which is a quarter. So 4 times 4, that's 16. So we have T naught here, then we have T16. T1, I can put it somewhere there. So the first payment is made here because of the word immediately. The last payment is made here at T16. Okay, so your N is going to be equal to what? 17. N is going to be 17. So F is 100,000. N is 17. X we don't know. I is going to be 0.12 over 4. Right? Are you following that? Right? Then let's put the formula. So I'm going to write my formula is F equal to X times 1 plus I raised to the power of N minus 1 all over I. All right. How many of you, because I just want some options here. How many of you would prefer me to make the X the subject before substituting the values? And how many of you would prefer me to substitute the values, then solve for that? Okay, let's substitute. So we put F is 100,000, X we don't know, so that will be 1 plus our I is 0.12 over 4, N is 17 minus 1, then you divide that by 0.12 over 4. All right. Now, you need to be very careful here. I don't encourage you to start putting values into your calculator whilst it's like this, because that can complicate things. So my suggestion is multiply this denominator here by that 100,000. Is that clear? You multiply those two. Okay? Then, whatever product you get, you divide it by whatever is in that square bracket. You agree with me there? So, you multiply the denominator by the 100,000. The product, you divide it by whatever answer you get inside the square bracket. Now, you don't have to use the calculator many times. You can do that at once. So, I can write a formula from here to determine X, right? And that formula will be X is equal to, right? Please, if you feel that maybe you're not getting this part, you can raise your hand, then I can redo it, right? So I'm going to repeat what I'm doing. I want to calculate X. So first thing, from my knowledge of equations, I need to multiply this denominator by 100,000. Then I need to divide both sides of the equation by whatever is inside the square bracket. Are you following that? Right? So once I divide by whatever is inside the square bracket, that answer will be equivalent to what? To x. So I can say 100,000 times this denominator, 0, comma, but let me recalculate.
Yes, please.
Yeah, you can. You can, but I don't want to do it that way. But 0.12 over 4 all over everything inside the square bracket. You still get the same result. 1 plus 0.12 over 4 raised to the power of 17 minus 1. Then you close the square bracket. Okay? Are you following there? Alright, then let's use our calculator. So you take out your calculator. Remember, you have to be a guru of your calculator. Right? So, first thing there, I'll start by putting my fraction option. Then I'm going to enter the numerator there, the 100,000 times the interest part. So it will be 100,000 times 0.12 divided by 4, right, all over. Now, first you have to put your square bracket, right, 1 plus the interest part, which is a fraction, 0.12 divided by 4, then you close the bracket, then put the exponent, which is 17, then you subtract 1 from it, then you close the bracket. Right? You following that? Make sure you are very careful when you are using your calculator, because it's very easy to make a silly mistake. Then you get that answer there. Obviously, your answer must be less than 100,000. Okay, avoid that. Avoid that. All right, so it's 4,595. Okay, right, let me write it down here. X will be equal to 4,595. The cents, we have got 25 cents. So, and 25 cents. So, this is obviously money. Okay, yes. Okay. All right, look here. If I give you, let me. We are now doing a question on calculating n. Right? Now, how do I know that you're supposed to calculate n? Let's read the question. Right? The question says, Yako wants to save 25,000 rand to redo. Okay, please, I'm pronouncing it as if I'm Afrikaans, all right? Right? So Yako wants to save up 25,000 rand to redo his swimming pool. So F is 25 what? Thousand. He can afford to save 100,000. Sorry, he can manage to save 1,000 a month. Okay? You can manage to save 1,000 per month. Now, because we have got this 1,000 and that man, it's a clue that we are dealing with an annuity. But which one? The future value, because he wants to save money. So those are clues that you must look at when you get a question in financial maths in grade 12. Right? The interest rate on his savings account is 6% per annum compounded monthly. The interest rate is fixed, it doesn't change. Right? How long? That's time now. How long? The moment you see a question saying how long when you're dealing with a future value, it means logarithms must come into your head. Logs. Okay? So to say before you said at least 25,000. So let's just draw a short timeline. So our timeline looks like this. Now, in this question here, there is no word immediately. Right? So it means the first payment is going to be made at T1. There is no word immediately. So we have T0, T1, and then we have got. Now, the total number of years is the one that we want to calculate. We don't know.
Yes, yes, n times that one.
We don't rush to say that. So it will be n times the compounding period, which is monthly. So I'll put 12n in. I'm putting 12n, but it's not entirely correct. Let me use a different variable. 12k. Yes, where my n is equal to 12k. K, look, k will be the number of years. I don't know the number of years. Is it given? Are the number of years given? And what is the definition of n that I gave you earlier in the morning? Number of payments. So the number of payments is equal to the compounding period times what? Times the number of years. Sometimes you can add one, but for this question here, since we are not told that he's going to make a payment immediately, we can't say there's a payment he's going to make here. The first payment will be made there at T1. It's only when you include T0 if the question says a deposit was made immediately. Are you following that? All right. So this is what we have. Then what are we given? We are given F is 25,000, and we don't know. That's the one we want to calculate. Then our interest rate 6.9%, so that is 0.069 over 12, right? And X is 1,000 rand, right? Then I'll write down my formula. F equal to X times 1 plus I raised to the power of n minus 1, close the bracket, divided by I. All right, now let's carry on now. Substitution. We are going to substitute. The objective is to calculate n. The objective is to calculate n. Then, if I substitute, I'm going to have 25,000 on the left, then 1,000 times 1 plus 0.069 over 12, all raised to the power of, well, let's put n here, minus 1, right, divided by 0.069 over 12. That's all. I don't expect such a question. All right. Are you following what I just did? So I've identified all my variables in terms of their values. Now the next thing, can I have your attention? Next thing now, we want to calculate n. So my suggestion would be multiply this value by 25,000. Right? Then the product or the answer that you get, divide it Okay, divided by 1000. All right? Don't worry, I'm gonna simplify it, but I'm explaining the steps. So first thing, multiply that interest part, which is part of the denominator, by 25,000. That product divide by what? By 1,000. When you do that, you are gonna eliminate the square brackets, right? So you'll be left with this minus 1 here. You take that minus 1 to the left, then it becomes a positive 1. Are you following that? So let me show you what I'm talking about. So, so you end up having 25,000 times 0.069 over 12. Then you divide this by 1,000. Then we subtract 1 from, we add 1 to it. This will be equal to 1 plus 0.069 over 12. This is raised to the power of n. Now we have, listen, now we have an exponential equation. Then you bring in the log. Right? Now, listen carefully. The number that we are going to find its logarithm is this one here. Let me put it in red. It's this whole number here. The one that I'm putting in red, that's the number that you are going to find its logarithm. Right? The base of that logarithm is this exponent, this sum here. Right? That sum there. That will be the base. Okay? So here we have got a number that we are trying to find its logarithm, which is a little bit complex, right? So n, like, allow me to do it on the next page. Allow me to do it on the next page, right? So let's do it on the next page. So n, okay, n is going to be equal to the logarithm. Your base is 1 plus 0.069 over 12. That's the base. The number that you are trying to find its logarithm is going to be 25,000 times 0.069 over 12. Then, okay, wait, you have to be very careful here. Let me remove this bracket.
So you can simplify it.
Yeah, that's what I'm going to do. But I don't want to, I just want to put everything in the calculator at once. Right, so let me remove that. I think I put it too soon. So we divide this by 1,000. Whatever answer you get, you add 1 to it. Alright? Then now I can put it inside the bracket. So this is the number that we are going to find its logarithm. The good thing is we can put everything in the calculator at once. Avoid using a calculator more than once. They make mistakes along the way. And avoid converting values to decimals. Right? So let's bring the calculator. So the calculator, you have to be very careful. So here, we are going to say logarithm, okay? The base, our base is that. So it's going to be 1 plus fraction option, that's 0.069 divided by 12. So I'm done with the base now. Are you following that? Then now I need to put the number that I'm finding its logarithm. So that will be, now I have to put fraction option, okay? Fraction option. Be very careful there. Be very, very careful when you're putting the values in your calculator. So 25,000, right? Times another fraction option, 0.069. I hope you are following. Over 12, right? I'm almost there. Then I have to divide this by 1,000, right? Then since the calculator has put a bracket for me there, that plus 1 must be inside the bracket, not outside. Because remember we said it's one number, right? So I have to add I'm adding 1 to that number. Right? Then you can hold your breath because if I made a mistake, the calculator will say math error, then I have to start afresh. Let's see if I'm a good of a calculator or not. Hey, can you pay attention? Okay. So fortunately, I entered all the information correctly, and the calculator gives me that answer. All right? Okay. So n. Okay. Now this 23,42 is the number of payments. The person was saying how long? Am I right? Now, since our compounding period is 12, then we divide this answer by what? By 12. Okay, let's say, this is just for interest sake. If the person was saying, what is the total number of payments, what would be the answer? Before you go, I'm saying if the answer was saying determine the number of payments, is the answer gonna be 23 or 24?
23.
It will be 24. Okay, let me explain to you before we go. Listen, it will be 24 because 23 of the payment will be full payment of 1,000. The 24th one will be fraction of a what? Of 1,000. Right. So our answer, we divide this by 12 and we'll get 1 year and 1,95 months, which is close to 2 years. So n is gonna be 1,95 years. And then you are done.
Correct. Thank you, sir.